Okay, so here I've recreated that animation from Desmos where we have the X and Y coordinates and the R and theta coordinates to get to that same point, X comma Y. And let's write down that that's also equal to R theta. By the way, we always do X comma Y. That's kind of a convention that we always put the X coordinate first and then the Y coordinate. Um, with polar coordinates, we always put the R coordinate first and then the theta coordinate. Okay. All right, so I'm going to write down some relationships here. The first one is going to be things that we will use to convert from polar to rectangular. For these, we're going to use our good old-fashioned SOHCAHTOA rules for our right triangle that we've created here. Okay, so remember the SOHCAHTOA. Okay, so would tell us that the sine of theta in that picture, opposite over hypotenuse, would be y over r. And the ka would tell us that the cosine of theta would be adjacent over hypotenuse, so x over r. All right, so I'm just going to multiply both sides of those relationships by r. To cancel this out, and that's going to give us a formula for x and y. So I'm going to put that over here. X is equal to r cosine theta, and y is equal to r sine theta. Okay, so if you know r and theta, you can plug into those formulas to figure out x and y. All right, going the other way, we need formulas that are going to help us get from rectangular to polar. Okay, so this is still going to be based on the right triangle. We're going to use the TOA, the tangent, in a second, but the first one is the easiest one that we've kind of overlooked, and that's the Pythagorean theorem. So if you just look at our right triangle there, x squared plus y squared is going to be equal to r squared. That's a squared plus b squared equals c squared. I'm going to write this with the r first. R squared, our hypotenuse, equals x squared plus y squared. So if we know x and y, we can use that formula to figure out r. And the last one, to figure out theta, we're going to use this tangent formula because we know that tangent theta, the TOA, opposite over adjacent, would be y over x. All right. And so if we know y and x, then we can kind of use the tangent to figure out what theta is. This is kind of the most disappointing formula of the bunch, that tangent theta equals y over x. So we'll save that one for the end. Okay, so let's do a couple of examples trying to use these formulas to convert back and forth between polar and rectangular. Okay, so I've copied our formulas here. Let's go ahead and pick a couple of points to convert from polar to rectangular and rectangular to polar. Okay, so let's start. We're going to convert. Let's see, we're going to do 2 comma pi over 3 to rectangular. All right, so when they're asking us to convert to rectangular, that implies that this already is in polar coordinates. So we're just going to use our x and y formulas there from the top of our formula. Let's make this a formula box over here. All right, so this is my r, and this is my theta. Again, we always list those in that order when we're doing polar coordinates. And I'm just going to plug into my x and y formula. So x equals r cosine theta, and y equals r sine theta. Okay, so you may need to pull out that unit circle to remember what the sine and cosine of pi over 3 are. Cosine of pi over 3 is a half. So this is 2 times a half. And sine of pi over 3 is square root of 3 over 2. All right, so then we just simplify those. We can kind of cancel out these 2's everywhere. And I get 1, and here I get square root of 3. Okay, so in rectangular coordinates, this point is the point 1 comma square root of 3, right? And then let's do one more of those. Let's do the point, let's say 3 comma 3 pi over 2. All right, so you can go ahead and just plug in. You can plug in your x equals 3 cosine 3 pi over 2 and y equals 3 sine 3 pi over 2. All right, and then go to your unit circle and figure out what sine and cosine of 3 pi over 2 are. Right? Or if you kind of think about it, this is really an easy one to convert. So I'm going to think about that point 3 comma 3 pi over 2. Okay, so 3 pi over 2 is the angle that wraps around and brings me down to the bottom. And if I'm going 3 tick marks in that direction in polar coordinates, I can just kind of look at that and say, I know what the rectangular equations for the rectangular coordinates are for that. That's just the point 0, -3. Okay, so if you can look at a point and figure out what its coordinates are in the other set of coordinates, you don't need to go through the problem of, the difficulty of using the formulas. All right, so that's converting polar coordinates to rectangular. So now let's do a couple that are converting rectangular to polar. So let's start off with the point -4, comma 0. Okay, so this is an x comma y, and I'm going to convert this to polar. All right, so I can use my formulas over here again, but again, this one is really easy to figure out if you just plot the point. Okay, so think about the point for, we're in rectangular, so this is your regular old 1, 2, 3, 4, -4, comma 0. All right, and that point, I just need to figure out the radius and the theta. The theta I need for this one, well, that's just pi, right? So I'm gonna go out to pi and I'm gonna walk 4 tick marks in that direction. So my r comma theta is just gonna be 4 comma pi. Okay, and you would absolutely figure that out by looking at the conversion formulas on the page. But if you can just graph it and think about it, that's certainly the easiest way to do it. Okay, so let's do one where you actually have to use the formulas. Let's figure out, let's convert 3, no, yeah, let's do 3 comma 3. I forgot to say we need to convert to polar. All right, so we're going to convert 3 comma 3 to polar coordinates. All right, so the first thing I'm going to use is that r squared Pythagorean theorem equation. So I'm going to say to figure out r squared, this is my x and my y. So I'm just going to plug in r squared equals x squared plus y squared. And I get 9 plus 9, it's 18. Take the square root of both sides. Normally we say plus or minus. Polar coordinates are always easier to think about if r is positive, so I'm just going to take the positive square root of 18. Like we have seen, you certainly can have negative values of r, so feel free to choose that if you want. And a better answer for that is going to be 3 times the square root of 2. Okay, that comes from noting that 18 is 9 times 2 and pulling the 9 out of the square root. It's not necessary, but it sure does look better. Okay, so 3 roots of 2 is my r, and now I need to figure out theta. This is probably the hardest part of it. Tangent of theta equals y over x. So I'm going to have tangent of theta equals 1. All right, and then I have to think about what the angle theta might be. Okay, so I got to think about where around my unit circle does tangent equal to 1. Okay, so tangent, I mean, you may be able to just kind of look and figure it out, but remember that tangent is sine over cosine. So we're looking for points on the unit circle where the sine divided by the cosine is equal to 1. That means where sine and cosine are equal to each other. Then that happens at 2 spots on the unit circle. There's pi over 4, where you get, see if I can write this small enough. There we go, I did. Okay, so that's where you get sine over cosine to equal to 1. It also happens down here in the third quadrant at 5 pi over 4. And that's where the terminal point is negative, comma negative. And again, hopefully you've got a unit circle sitting in front of you and you can just kind of poke around for these two. So I got pi over 4 in the first quadrant, 5 pi over 4 in the third quadrant. Okay, so then you just got to ask yourself, which quadrant is this point in? Well, the point was 3 comma 3 in rectangular coordinates, so like 3 comma 3, it's in the first quadrant. So that pi over 4 angle is the one that you're looking for. Okay, so theta must be equal to pi over 4. All right, so our point is going to be 3 square roots of 2 comma pi over 4. Right, and again, polar representations of points are not unique, so there's actually an infinite number of correct answers. Doesn't mean you can put anything you want, but there are an infinite number of correct answers that will get you to the point 3 comma 3 as well. All right, so that's it for this video, and we will finish up this section when we meet together in class again.